quite a while ago in our section on the number e, we came up with this, meaning that if we want to compute the number e, we would use this. We would select a number that's really big, near infinity, and then put it into here, and then this whole thing here would give us an approximation for the number e. So, for example, select a number that's really big, maybe bigger than this. Select a number that's really big here, put it into here and into here. That will then give us this, and then the whole thing here will give us an approximation for the number e. Okay, so starting from here, looking at this, looking at this here, if you so we would use this to compute our approximation for the number e. We would select a number that's really big, and put it into the n here. Okay, but looking at this, if you natural log both sides, so if you natural log this side, natural log this side, this n here would go over here, giving you this n here. Well, starting from here, if you natural log both sides, that will then take you to here. Now, when you are here, when you're doing your algebra, if you're manipulating, if you're manipulating things about, moving your algebra about, and you get to this stage here, you see, if you have a knowledge of approximation, you would then realize that this whole thing here is actually approximately 1 when n is very big, when n heads towards infinity. Well, the point I'm trying to make is that if you're here and then you're manipulating things about, you get to this stage here. You see, looking at this, you don't really understand what's going on here. But if you have an understanding of approximation, you can actually say that this whole thing here is approximately 1 as n tends to infinity, because at the moment you've got this block times this block here, and remember, natural log of this is approximately, so this here is a linear approximation. So when you have the natural log of something here, that's approximately something here. Okay, so going back to here, if you're here and then you're manipulating things about and you happen to get to this stage here, by having an understanding of linear approximation, you will realize that this thing here is approximately this times, well, this thing here is approximately 1 over n as n gets very big. So this thing here gets multiplied to the top here, and then this is approximately 1. So you can say that the natural log of this thing here, as if you select an n that's really big, it will approximately be 1. The point I'm trying to make is that if you're here and then you happen to be manipulating things, and then you get to this stage here, looking at this, you don't really have a sense of what's going on. But by you having an understanding of linear approximation or any sort of approximation, you will realize that this thing here is roughly this. Okay, and then this is n here, and then this n gets multiplied to the top, meaning that in your mind you should teach yourself to be able to see that this is approximately 1 if n is really big. Okay, so the point that I'm trying to make is that when you have an understanding of linear, when you have an understanding of approximations, you can greatly simplify things and realize that this whole thing here is actually approximately 1. Okay.